in statistics, we always, when we're looking at numerical data, we always want to describe the middle, the center data observation. You know, if you had a bunch of test scores, you might be interested, well, what's the average? What's the one in the middle? Because if you knew the center, then you knew that maybe half of the data values are higher and half of the data values are lower. So one number that describes the center is one that we're always looking for. And there are four measures that we use. The mean, and this is what we call the arithmetic average. The variable that we use for this, we use all kinds of different variables, but X with a line over it is what we use for the mean. And it's called the X bar, that's how we say it. And you'll need to know that terminology because at some point we're going to be going to the graphing calculator, and that's how the graphing calculator, the variable that it shows for calculating the mean. An example is if you had 4 test scores. So you're very familiar with this because you've probably calculated it many times. If you have a 75 and a 95 and an 85 and an 85, if those are your test scores, then this says this is the Greek letter sigma, which in math means the sum. So the sum of all the test scores. So X equals test score. And so we're summing up all the test scores, and N is equal to the number of test scores. In general, N is equal to the sample size. So since we have 4 test scores, we divide by 4. So we would add those 4 numbers together, get the sum, and then divide by 4. And then we would say that the average was 85. So this is probably something that you calculated in the past. Here's another one, the mean for a frequency distribution, where F is the frequency, the count of that particular class, of each class. And X is equal to the data value. So you're going to calculate the number of times that X appears. You're going to sum them all together and then divide by the N. Let me give you an example here. So let's say that we wanted to ask students how many pets they have in their house. And some students say, well, I have 0 pets. Some students say I have 1, and some say I have 2. I'm just going to use a simple example. And here's the frequency over here. And so the pets, number of pets is the data value. And let's say that 5 students said that they have 0 pets. 15 students said that they had 1 pet. And then 10 students said that they had 2 pets. So when you add up all these frequencies, this is the value of N. This is the total number of students that participated in, let's say, the survey. 5 said 0, 15 said 1, 10 said 2. If you add those together, you get 30. So there are 30 students that participated in the survey. What this formula says is that we're going to take the data value and multiply it by the frequency. Data value multiplied by the frequency. And then this says sum them up. So we're going to multiply by 0 times 5, 1 times 15, and 2 times 10. We're going to multiply each of these numbers, the X times the F, X times the F, X times the F, add them all together. Then we're going to divide by the n, which is 30. This is 20. This is 15. That's 0. Add those three together to get 35. And then you would calculate the average, and it would be this. So we would say the average would be just over 1. So on average, we would say that students who participated in this survey have about one pet in their family. All right, so mean, a couple of measures of mean. The next one is the median. The median is the equals the middle data value. So it's important that when we talk about the middle data value, it's after all the data values have been sorted from smallest to largest, or largest to smallest, usually smallest to largest. And then it's the middle data value. And if we have an odd number of data values, then there will be a middle one. If we have an even number of data values, there will not be a middle one. So in that case, what we do is we grab the two middle data values and then take the arithmetic average, the mean of the two middle ones. Midpoint, average, mean, all of these mean the same thing in this context of the middle two data values. So what this says here is if you have, say, 51 data values, then you would have 25 here, 1 in the middle, and then 25 here. 25 plus 1 plus 25, there are 51 data values. And the median is in the middle spot. Notice it's in the 25, in the 26th position. And that's what this formula is doing here. If n is equal to 51, then n plus 1 over 2 is 51 plus 1 over 2. And that works out to be 26. So the median would be in the 26th position. So median is the middle data value, which is in the center. The mean is the arithmetic average. It's like calculating your test scores. The third one is the mode. The mode is the most frequently occurring data value, the most popular one. Up here, if we had 5 zeros and 15 ones and 10 twos, the data value that appears most often is 1. So 1 is the mode. The mode is the data value that occurs most often in the data set. It would help to determine the mode if you have a numerical set of data that you actually sort the data. It's easier to determine the mode that way as well. So mean and median and mode, and the last one is the mid-range. We'll see later that the distance from the smallest data value to the largest data value, if we subtract those two, max minus the min, we get the range. So if the minimum data value was 3 and the maximum data value was 23, then the number right in the middle, right there, is called the mid-range. It's midway through the range. And the way we get it is we take 3, smallest data value, plus 23, the largest data value, and then divide by 2. 26 divided by 2, it would be 13. So the lowest data value is what we call the minimum. The highest data value is what we call the max. And it's like you're taking the midpoint between the max and the min, halfway between the max and the min. That's the mid-range. Okay, let's take a look at some examples. Use each display of data items to find the mean, the median, the mode, and the mid-range. Now here's a table, and if you wrote, or it's a graph, and if you wrote a corresponding table for the frequency, this data, the data values are 10, 20, 30, 40, and 50. 10, 20, 30, 40, and 50. Now, if you go up to the height of the 10, you'll see that there are 5 of those 10s. So there are 5 10s, and the data value 20, there are 3 of them. The data value 30, there are 2. Data value 40 and 50 each one. So if you add up these data value, the frequencies, you get 5, 6, 7, 8, 9, 10, 11, 12. There are 12 different data values. This is the total number of data values. This is our value of n, the number of data values. Now, if you write those data values out from smallest to largest, this is what those 12 data values would look like. You would have 10 appearing 5 times. Then you would have 20 appearing 3 times. Then you'd have 30 appearing 2 times. And then you have 140 and 150. And if you count them up, you get 12 different data values. So 3 different ways to represent the same set of data that we're working with. Okay, enter into the quiz box, or into the chat box, not the quiz box. What's the mode? The mode is the most frequently occurring data value. What's the mode? Go ahead and enter it over there in the chat box. Just 2, 3? Okay, I see 5 answers. They're all correct. It's 10. All right, now let's move on to median. Now the median is the middle data value, provided that there's an odd number, odd in the mathematical sense. In this case, there's an even number of data values. So there are 6 data values on the low side and 6 data values on the high side. So 6 and 6. So what we do is we take the middle 2 data values and we find the number right between them. What's the midpoint? What's right between 20 and 20? That would be the median. In this case, it's just the number that has to be between these two is 20. It's the only number that would work. If you wanted to take the arithmetic average, you'd add those 2 numbers together and divide by 2. There's no middle one this time, so we average the 2 middle data values. The mid-range, and that's the midpoint between the largest and the smallest data value. So take the smallest data value, 10, and the largest data value, which is 50. And you ask yourself, what data value comes right between those two? 60 over 2, which is 30. So 30 is the mid-range. You can even draw a picture of this one. Here's 10, here's 50. What goes right there? That's the mid-range. Midway through the range. And finally, the mean is equal to, you got to add all these together and then divide by 12. So 10 plus 10 plus 10 plus 10 plus 10, 50. 60, 70, 80, 90, 110, 140, 170, 260. Gosh, I hope I have that right. 260 divided by 12. I did it quickly in my head, but 50 plus 40 plus 50 plus 120. 260, yeah, that's what it is. So 260 divided by 12, and that is approximately 21.667. All right, so all of these numbers should kind of be in the ballpark. They're not that great right now because we have a real small data set, only 12 data values. But since they all give us a measure of center, they all should be fairly close. And in this case, they're not so much. Okay, so the next thing I want to do is when you get a data set, especially when you're dealing with bigger numbers and you have to calculate a more sophisticated statistic like a standard deviation, it makes sense to enter the data values into your calculator. So let me show you, and you can walk along with me on this. Go ahead and get your calculator out. And what we want to do is let's go down to this one right here, and let's enter in these 24 data values into a list. All right, so you know how to enter data. You've done it several times in different contexts here, but you want to hit the Stat button, and then to enter in the data, you want to go to the very first option there, which is the list. If you want to clear out these data values, just hit clear and then enter. So that frees up this list. Now let's enter in all of the data values as you see them there. And it'll take a little bit of time because there are 24 of them and they're each 3 digits, 4 digits, 4 characters long, but that's okay. It's not too bad. Okay, so here they are. I'll scroll through this again to make sure everything's correct, but there's our 650. It's in position 24, and there are 24 data values. Now, these data values in this table are not sorted, and so it's hard to figure out what the median is. And these are the average reading speed of people who complete this speed reading class. And this advertisement said that the average, notice it's in quotes, the average could be just about any one of those 4 measures of center we're talking about. Usually average means the mean, but let's see if this, they say that the average reading speed is 1,000. Let's see what statistic they're actually using here and if that makes sense. So what we're going to do is we're going to calculate the mean, the median, the mode, and the mid-range of this data set. So when you have a large data set, the most difficult calculation is the mean. So I'm going to do a couple of things here. I've got all those data values sitting in L1, and that's the first thing you want to do. So enter the data in L1. And then what we're going to do is we're going to ask the calculator to calculate as many of these as we can. And so in the stat menu here, a lot of the stuff we do with statistics originates from this menu. We're going to hit that. And then we want to calculate something. In this case, we want to calculate the mean, median, and anything else it'll give us. When you want to calculate something, you go over to this middle menu. And we've done some work with linear regression here, so you're somewhat familiar with that, and quadratic regression and so on. But the one we want here is the first option. This gives us the statistics that correspond to the single variable. Which variable? Well, it's the variable where we entered our data, usually L1. So I'm going to select one variable statistics. Now, the first thing, I have an old calculator. You might have one that has a menu that comes up. So you want the X list, and the X list should be L1. And then the frequency list can be, just leave that blank because you're not going to be using a frequency list. These are just data values that appear a single time. And that's it. And then you paste this in here, and this is what you get. Now, I mentioned at the beginning that X bar is the variable that we use for the mean. And so you could add up all 24 of these data values and divide by 24, or you could just punch them into the calculator and come up with this number here. I'm going to round this. Now the median, there are 24 data values. So we have 12 here and 12 here. So if they're ordered, we have to go and grab the 12th data value, which is right here, and then the one right next to it, which is the 13th. And we'll average the two middle data values. By the way, the calculator gives you the mean, and then there's a little arrow down there. You can see that we have 24 data values. Here's the standard deviation that we're going to calculate in the next section. It's the SX. And that's a very complicated calculation, particularly if you have a lot of data values like 1,000, and particularly if you have a messy mean. It's a very tough calculation. That down arrow there means that there's something down under, and if you scroll down, you'll see, oh, the median, that MED is an abbreviation for median. The median is equal to 850. Now, let me show you how you can get that from your list. We're going to go back into the list, and notice none of these data values are sorted. All right, so I'm just going to make a copy of it over here. Now what I'm going to do is to quit, to go back to my home screen, and then go back to the stat menu here, and I'm going to sort that list L1 so that all the data values are in order. That would enable me to find the median. Of course, I already know the median is 850, but I'm calculating the median in a slightly different way. So we're going to sort the list, and I'm going to enter in L1. Okay. There's L1 right there. It's in blue, so I have to hit the second key to get it. And then second, the number 1 would give me L1. So this says I want to sort. The A means in ascending order. I want to sort in ascending order the data values in L1. I'm going to hit enter, and it just says done. So that means that it went ahead and it sorted it. So just to see that it sorted it, I'm going to go back and look at my list. Stat, and then edit. And now look, all of these are sorted. Here's the original list, and here's the list sorted. Now I have to go down to the 12th and the 13th data value. In the sorted list, there's the 12th, and there's the 13th. And so 850 and 850. So you know what that is. 850 plus 850. Take the midpoint between those two, and you get 850. When you have them sorted like this too, it's easier to pick out the mode. So the mode is the most frequently occurring data value. So if you look through this list, you have 3 800s, 1, 2, 3, 3 850s, 3 900s, 2 950s, 4 1000s. So what is the mode? Most frequently occurring data value. Thank you. 1,000. So it must have been the case that when they said average, they used the mode, which is never one that we would use. You know, most people score lower than the 1,000, as you can see. So it's somewhat false advertising. All right, so the mid-range, you can see from the list here that the maximum data value is 1,100. And if we scroll up to the top of the list, the minimum data value is 600. So we're going to add the min, 600, with the max, 1,100, and then divide by 2. That's the formula for the midpoint. 1,700, and guess what that is? Also 850. So in this case, the median, the mean, and the mid-range, all of them are very, very close, almost the same thing, 850. But then we have this mode that's 1,000, and that's the one they reported. Probably false advertising. All right, so which measure did they, of central tendency, did they actually report? They reported the mode. And the one that is the best indicator, well, I would say any one of these other three, but probably the mean would be the best. It's the arithmetic average. And sometimes the median would be best as well, particularly if you have like one person that has a very slow reading speed and someone that has, or maybe someone that has a very high speed. That would be best. Okay, so mean and median and mode, and there were just a collection of problems.